Hello students, good morning. In last lecture, we have studied about definition of integration, different formulas of integration, then algebra of integration, that is the addition of two functions is integrated then is equal to integration of the two separate functions, okay? As well as so many standard integrals we have seen. I know that all of you have studied it very well. Now today we are going to start methods of integration, that is how to find out integrals of the functions by various methods. And the first method is that integration by substitution. Okay. Now here to study this method we have to see one theorem first. It is a very easy method and you will enjoy it. I know that very well. So the theorem is that if x is equal to phi of t, means you know that x is a variable, and again we define x into in terms of another variable, that is t. So if x is equal to phi of t is a differentiable function of t, then integration of f(x) is equal to integration of f of phi of t into phi dash of t into dt. See the statement again. If x is equal to phi of t is a differentiable function of t, then integration of f(x) is equal to integration of f of phi of t into phi dash of t into dt. That is, here the original function is fx and we are going to make a substitution that here x is equal to phi of t, that is x will be replaced by another variable, that is phi of t. So see what is the proof of this theorem. It is too easy to understand, okay? If you see it carefully then you will easily get understand. So let us consider what is given here. It is given that x is equal to phi of t. Let us assume this is equation number 1. It becomes very convenient to understand the theorem if you numberize the equations, okay? Now to avoid the confusion, I am numbering the equations, okay? So don't get confused due to these numbers. X is equal to phi of t is a differentiable function of t. It is given. Differentiable means what? If we differentiate x with respect to t, then its derivative get exist. So we have dx by dt is equal to phi dash of t. Let us consider this is as equation number 2. Okay. Now let integration of fx dx is equal to g of x and say it is equation number 3. Now if we differentiate equation number 3 with respect to x, then we will have d by dx of g of x, isn't it? Here derivative of g of x with respect to x is equal to derivative cancels integration and we have only fx. Say it is equation number 4. Now, and this happens what? This happens due to by definition of integration, okay? Now by chain rule, what do we want to prove by chain rule? Now let us consider derivative of the same function g of x, okay, which is the integral of e of x. Consider derivative of g of x with respect to a new variable, that is t, okay? Here you can see that g is a function of x, okay, and still we are differentiating it with respect to t. Why? And how we can differentiate it? Because though g is a function of x, but x is a function of t, and hence by using chain rule we can differentiate this function with respect to t also. Now how? First, since g is a function of x, therefore take its derivative with respect to x. That is derivative of g of x with respect to x and into derivative of x with respect to this x, derivative of x with respect to t, that is dx by dt, isn't it? Now these two terms we have already taken there from equation 2 and 4. You can see here dx by dt is equal to phi dash of t and derivative of g of x with respect to x is equal to fx. Hence, by taking the reference of equation 2 and 4, this equation becomes, this term becomes fx and this term becomes phi dash of t. Okay. Now, here the equation is now d by dt of g of x is equal to f of phi of t into phi dash of t. Now here this term phi of t is obtained from where? This x is replaced by phi of t. And from where? It is given in the statement itself. X is equal to phi of t. And we have mentioned it already as equation number 1. So therefore, d by dt of g of x is equal to f of phi of t into phi dash of t. Okay. And now, this equation can be changed to integral form or reduced to integral form by taking integration. So if we integrate both the sides with respect to t, why it is so? Because here we have differentiated with respect to 2, that's why we have to integrate also with respect to t. So integrating with respect to t, we get this d by dt get cancelled, we have only gx. And here to the RHS, integration of f of phi of t into phi dash of t and this coefficient of integration, that is dt, isn't it? Because we are integrating with respect to t, that's why we have to add it here. Now RHS, in RHS we add only integral sign and this term dt. Now come to the LHS. Here gx, what is this gx? We have already make a substitution for it from equation number 3. What is gx? Gx is nothing but integration of f of x dx. And hence replacing this term from equation 3, we get integration of f x dx is equal to integration of f of phi of t into phi dash of t into dt, isn't it? And you can see this is our required proof, that is if x is a function of phi of t and it is differentiable function of t, okay, integration of fx dx is equal to, after substitution, f of phi of t into phi dash of t into dt. Students, see, this theorem is too easy to understand. If you numberize the equations sequentially and if you go in this way and if you have understood the definition of integration, that is integration cancels derivative or derivative cancels integration, then you will easily, there are so few steps are there. Now let us take overlook again here. See, let us consider here x is equal to phi of t. Okay, equation number 1 is a differentiable function of t. Therefore dx by dt is equal to phi dash of t. 2. Then let us consider integration of fx dx is equal to g of x. If we differentiate this equation, then d by dx of gx is equal to fx. Now differentiate the same function with respect to t. Therefore by chain rule we have here d by dt of g of x, first derivative of g of x with respect to x and into derivative of x with respect to t. Replace terms by fx and this term by phi dash of t, but x is equal to phi of t. Therefore we have d by dt of gx is equal to f of phi of t into phi dash of t. Now integrate this equation, that is both the sides with respect to t. Therefore we have gx is equal to integration of f of phi of t into phi dash of t into dt. Again replace this gx by integration of fx dx is equal to integration of f of phi of t into phi dash of t into dt, isn't it? So this is the required proof. It may be asked in exam. Okay, it is already asked so many times in exam, so you can prepare according to this way also. That is, it will be very helpful. If it is asked in exam, then it will be asked for 3 or 4 marks along with simple example also. Okay,
Here,
so prepare it
to illustrate
and we
this
will go
theorem,
to the. Okay, it is too easy. And how can we illustrate it? So let us consider one example to illustrate this theorem. Okay, so here let I is equal to integration of 3x square into sine x cube dx. Okay, now what substitution we can make here? So first we have to find out, is there any derivative lies of any term? So yes, you may got it. I know that. Here x cube, and x cube has derivative 3x square, isn't it? So it is too easy to understand. So we have to make a substitution. What then? So put x cube is equal to t, or you may write t is equal to x cube, doesn't matter. X cube is equal to t. Now differentiate this equation with respect to x. Listen carefully, differentiate with respect to x. Therefore, derivative of x cube is 3x square only, and derivative of t with respect to x is dt by dx. But I have adjusted this term to the LHS already. Because what? Because I want to find out the value of this whole term in terms of a new substituted variable, that is what? T. So I write this as derivative of x cube 3x square into dx and is equal to dt. So value of this whole term is equal to dt, because after substitution I do not want any term in the original integral in terms of a old variable x. I want all the terms in terms of new variable t. Remember that. There should not be x again. Okay? Up to we do not integrate the function. Listen it carefully. So we get now x cube is equal to t and 3x square dx is equal to dt. Okay, this is the first example, that's why I am explaining it to. Further, in further examples there is no need such a having such more explanation. Okay, so here equation 1 becomes, after substitution, now 3x square dx is equal to dt, and sine x cube is replaced by t, therefore it becomes sine t. Hence the function becomes or reduced to the new variable sine t into dt. Remember that only the terms of x get replaced, sine remains as it is. Therefore I is equal to, what is the integration of now sine? Sine has integration minus cos, variable as it is, that is t, plus c. But our original function is in terms of x, so we also want in terms of x. So it is corollary we 1. Also want our answer in
if you
terms of
remember
x.
that I have already
So again,
explained you
by
in
back
the remark
substitution
before in previous lecture.
back substitution, what
If
is
back
back substitution?
substitution
T
f
is
x dx
replaced by
to
what?
g of x
The substituted
plus
value.
c,
And what is it?
then
X cube.
integration
Hence,
of f
I
of
is
x
equal to
plus b
minus
dx
cos
is
t is
equal
replaced
to
by x cube,
this
cos
a
x cube plus
multiple
c.
or
And this is our
coefficient or scalar
required
of x
answer.
becomes
Now,
the
there
divisor,
are
that
some
is
more
1 by a,
results are
or as a
derived from
multiple
this
1 by
theorem,
a of
which are known
g
as
of
corollaries. These
x
results
plus
are
b, that is
also
the
too
integral function
important
g
for
of ax
solving the
plus b
example.
plus
So let us see
c.
the now.
Results.
Let us see how it is proved. So let us consider what is given there. Integration of fx dx is equal to gx. It is given. Okay. So we want to prove this one. Our aim is this one. So to prove this m, let us consider the LHS. I is equal to integration of f of ax plus b dx. Now, substitution. Now we want to change this variable. So make a substitution, put ax plus b is equal to t. Differentiate with respect to x. If we differentiate it with respect to x, then what happens? A into derivative of x1 plus 0 dx is equal to dt, that is a dx is equal to dt, that is a is equal to dx dt by dx, or dx is equal to 1 by a into dt. Isn't it? Equation number 1 becomes, after substitution, this is not equation number 1 here, this is 1. Equation number, say, 2. Equation 2 becomes, what it becomes now? I is equal to integration of f of t into dt by a. 1 by a is constant, taking outside the integral. Inside the integral, f of t dt. From equation 1 is equal to g of t plus c. Okay. Therefore, again, we want to replace this t to obtain our required result. But what is this t? Come here. T is equal to ax plus b. So by back substitution, I is equal to 1 by a g of x plus b plus c. Isn't it? And what is your I? Integration of f of x plus b dx is equal to 1 by a g of x plus b plus c. So simply what? After integration, the integral is multiplied by the coefficient of the variable x as 1 by a, and we have already seen it, so there is no need to explain it again. So come to the next. To understand the above theorem, let us consider one example. Let integration of a raised to 2x plus 3 dx is equal to integration of a raised to 2x plus 3 upon log a into multiple of x, that is 1 by 2 plus c. Okay, and we can give the reference of the integral, that is integration of a raised to x dx is equal to a raised to x upon log a plus c. Now corollary 2. Again, this is of the corollary we have seen for the function x raised to n, and now we want to prove for a function f(x) raised to n into f dash of x dx is equal to f of x raised to n plus 1 by n plus 1 plus c, where n is not equal to minus 1. N is not equal to minus 1, and I have already explained you why it should not be minus 1. This theorem is already proved, that is the previous theorem. Now come to the corollary number 3. You can see the proof of corollary 2 in your textbook and try to understand it and prove it. Now come to the third result, that is corollary 3. This corollary is very important. The result which is proved in this corollary is used so many times at the time of solving examples. Okay, so let us see carefully towards the proof of this corollary. It is too easy, too much easy, and too much easy to understand and to apply also. Okay, and too much important also. So what is that? Integration of f dash of x by fx dx is equal to log of mod of fx plus c. There is no need to put modulus sign, because in your new syllabus modulus sign is not given anywhere. It is given in your old syllabus. It was put every where that is the modular sign, but now in your new syllabus it is not given anywhere. So you can simply make a circular bracket also. So if the derivative is there at the numerator and the original function is at the denominator, okay, then its integral is what? Log of fx plus c. So let us see. Consider I is equal to integration of f dash of x by fx dx. Put fx is equal to t as usual. So take its derivative. Derivative is f dash of x dx is equal to dt. Isn't it? After substitution, I becomes f dash of x dx is equal to dt and fx is equal to t. Now we know that what is its integration? Dt by t, that is 1 by t into dt. So here the reference is given. Integration of 1 by x with respect to x is equal to log x. Therefore integration of 1 by t is log t plus c. Now again we want to obtain the result in terms of x. So by back substitution, t is replaced by what? Fx. Therefore we have this result, log f of x plus c. Therefore we have integration of f dash of x by fx dx is equal to log of mod of fx plus c. See students, it is very easy to prove the corollaries or theorem. What do you want to prove? It is given there. You have to only adjust the terms in terms of derivative and integration. No more calculations you have to do there. No formula is required, no calculations, no another changes, only derivative and integration. Fx is equal to t, f dash of dx is equal to dt, substitution dt by t, then its integration log of t plus c, then by back substitution log of fx plus c. So this is the required proof of the given corollary. Let us consider one example. This example also gives us one formula also. Here let us have I is equal to integration of minus tan x dx. Now taking negative sign outside the integral, therefore we have integration of sin x by cos x dx is equal to integration of minus sin x by cos x dx, and this is of the form integration of f dash of x by fx dx. Means what? We know that derivative of cos x is what? Minus sin x. You can directly write in this way, or you can go by using substitution method also. If you go with substitution method, then there is no need to write in this way, isn't it? So what we do? Put t is equal to cos x, isn't it? Then differentiate with respect to x. Therefore dt is equal to minus sin x dx. Therefore this equation becomes dt by t. Therefore I is equal to log of t plus c. But what is our t? By back substitution, log of cos x plus c. Therefore I is equal to log of cos x plus c. So this is our last corollary, fourth one. This result is also important, and this is you can use like a result. This one, integration of f dash of x by root of fx dx is equal to root fx plus c. Okay, there is proof given. Again make a substitution, that is put t is equal to root fx and then take, or sorry, put t is equal to fx, then you will have integration of dt by root t, and then taking its integration you will have the result 2 root fx plus c. So try to prove it, and you will have a result. And remember this formula: integration of f dash of x by root fx dx is equal to 2 root fx plus c. That is, in answer you will have the root fx same term which is multiplied only by 2. Students, we have seen corollaries. Now we are going to learn some integrals which we haven't seen before. Now integration of tan x dx. Now you know that tan x is not derivative of any function. But how to take integration of tan x? So we will derive it. See how? By using substitution method. So let us see I is equal to integration of tan x dx. Now tan x can be written as sin x by cos x dx. And you know that here sin x, this one, is derivative of cos x. But derivative of cos x is minus sin x. That's why we have to adjust this negative sign. Or you can go through the substitution method as put t is equal to cos x, then dt is equal to minus sin x dx. Okay, then there is no need to adjust this sign, you will automatically have a negative sign there. So here this is of the form f dash of x by fx, isn't it? So by using the corollary, integration of f dash of x by fx dx is equal to log of fx, and our fx is what? Cos x, and we have this negative sign already is there. So the integration of tan x is what? Minus log of cos x. Now we can adjust this negative sign as by the laws of logarithm. This is nothing but minus 1 as a multiple. So take this minus 1 which becomes a power of this cos x, that is cos x raised to minus 1. Okay. Then we can reduce this minus 1 to plus 1 by taking its inverse or reciprocal as 1 by cos x. And what is 1 by cos x? 1 by cos x is nothing but sec x. So due to this adjustment, this negative sign get absorbed and the result reduces to the form log of sec x plus c. So here the integration of tan x is equal to log of sec x plus c, and you can use the above result also, that is minus log of cos x plus c, but it is convenient to use the second result, that is log of sec
Similarly,
x
the another
plus
result.
integration of sec x dx is equal to log of sec x plus tan x plus c. So how we can obtain it? How we can derive it? So let us see there. Consider the LHS integration of sec x dx. Now multiply and divide this term by sec x plus tan x. So to the numerator, taking this product sec square x plus sec x tan x, and to the denominator sec x plus tan x as it is. Now sec x into tan x is the derivative of which function? It is the derivative of sec x, and sec square x is the derivative of tan x. So here numerator is the derivative of the denominator. So again this is in the form f dash of x by fx, and it is explained here: derivative of sec x plus tan x. Derivative of sec x is sec x tan x plus derivative of tan x is sec square x. Therefore, using this value here and by taking the reference of the corollary, integration of f dash of x by fx dx is equal to log of fx, that is log of sec x plus tan x, that is integration of sec x dx is equal to log of sec x plus tan x plus c. Again, for the same integral we can have another form also, and this form is obtained by using the convergence which we have learned in trigonometric functions in 11th standard, that is sec x can be written as 1 by cos x and tan x can be written as sin x by cos x, and solving this formula is reduces to the form tan of x by 2 plus pi by 4 and plus constant of integration c. This result is also very important and as well as very easy to simplify and to prove. You can prove this one. Take the reference from the textbook. Now go to the next one. We have proved that integration of tan x is equal to log of sec x plus c or minus log of cos x. So similarly, we can prove that integration of cot x dx by taking cot x as cos x upon sin x. And what is the derivative of sin x? Cos x. So is equal to log of sin x plus c. If you prove this one, then you will better understood. Now take the next one, integration of cos x dx. As like sec x, there we multiply by sec x plus tan x, and here you can multiply by cosec x minus cot x. Okay, you can multiply the function to the numerator and denominator by cos x minus cosec x minus cot x, and then you will have the required result, that is integration of cosec x dx is equal to log of cosec x minus cot x plus c. So these are the some integrals which you have learned right now. So remember these formulas which are very important. Consider an example. Integrate the following function with respect to x. 1. Log of x bracket raised to n by x. So again you have to find out first what is there a derivative of the function lies, and if you can do this, then you will easily solve the example and you will enjoy also solving such examples. So you can easily get that log x has derivative what? 1 by x, isn't it? Therefore, let us solve this example. Let us consider I is equal to integration of log of x raised to n by x dx. Say equation number 1. Now put log x is equal to t. Differentiate with respect to x. Then we have log x has derivative 1 by x and t has derivative dt by dx, which can be written as 1 by x dx dt. Therefore, after substitution, equation 1 becomes log x is replaced by t raised to n, isn't it? And 1 by x dx is equal to dt. But integration of this function, power get increased by 1 after integration. So t raised to n plus 1 upon n plus 1 plus c, isn't it? Now again replace this t by x. What is this t? Here, log x. Therefore, by back substitution, I is equal to log x raised to n plus 1 by n plus 1 plus c. Okay. So this is cot of log x by x dx. Again similarly, only cot is there. Again same substitution, put t is equal to log x 1 by x. Therefore, our function by substitution becomes cot of t. What is the integration of cot t? Is equal to log of sine of t plus c. Now by back substitution, t is equal to log x. Therefore, log of sine of log x plus. Okay. So let us see further examples also. Some more examples also given there. X is x into sec square x square by under root tan cube x square. Okay. Therefore, let us consider I is equal to x into sec square x square by under root tan cube x square. Now, what substitution? Which function is derivative of which one? So, you know that derivative of tan x is what? Sec square. Isn't it? Therefore, put tan x square, this tan x square is equal to t. Differentiate with respect to t. Sec square into x square into derivative of x square 2x dx and is equal to dt. Therefore, this x into sec square x square into dx and shift these two to the RHS. Therefore, it is dt by 2. Therefore, we will have after substitution 1 as 1 by root t cube into dt by 2. Therefore, I is equal to 1 by 2 constant, taking outside the integral, 1 by root t cube dt, 1 by 2. Now, to integrate this one, shift this term to the numerator. And what will be the power of t here? Its power is 3 and its root is 2. So the power of its collectively is that 3 by 2. And if we shift it to the numerator, then it positive becomes negative after taking a reciprocal or inverse. Therefore, after integration, power get increased by 1, that is minus 3 by 2 plus 1 upon minus 3 by 2 plus 1. Solving it, we have t raised to minus half by minus half plus c. Then these two get cancelled and we will have this minus 1, and t raised to minus half can be written as 1 by t raised to half, and 1 by t raised to half means root t plus c. Okay, and again replace this t by the, what is the substitution you made there already, hence by back substitution minus 1 by under root tan, here t is equal to x square plus c. So let us see. Students, come to the next example, that is integration of sec raised to 8x by cosec x dx. Now, to solve this example, let us consider there this sec raised to 8x can be written as sec raised to 7x into sec x into 1 by cosec x. Okay? Why? See, sec raised to 7x into 1 by cos x into this 1 by cosec x can be written as sin x dx, and sin by cos tan x, isn't it? Now, sec raised to again this 7, take 1 sec x here, then it becomes sec raised to 6x into sec x into this tan x. Now, put sec x is equal to t, because derivative of sec x is what? Sec x into tan x. And we are making this substitution for which sec x? This one, for this sec. And this term is taken as a derivative. So sec x into tan x dx is equal to dt. Therefore, I becomes, after substitution, what it becomes? I is equal to t. This t raised to 6 into whole this term is equal to what? Dt, into dt. Very simple form, power function, power get increased by 1. So t raised to 6 plus 1 by 6 plus 1 plus c. Now, by back substitution, reduce this t to again x. Therefore, what is t? Sec x. So, sec raised to 7x by 7 plus c. So, these are very simple examples. They look very difficult, but actually they are so simple. This is the example given here. I is equal to root tan x by sin x into cos x dx. Now here we have to make a small adjustment. Divide and multiply to the, sorry, divide numerator and denominator by cos square x. Then we will have here 1 cos x get here cancelled, and root tan x, this cos square x, taking its reciprocal, that is inverse sec square x. Then sin x by cos x is tan x. Now root tan x, this tan x can be written as root tan x into root tan x. Therefore 1 root tan x get cancelled and 1 remain. Now we know that derivative of tan x is what? Sec square x. So make a substitution. Put tan x is equal to t. Differentiate. Then we get sec square x derivative of tan x dx is equal to dt. Therefore, this I become this I. Sec square x dx is equal to dt, and root tan x becomes root t. Now this root t can be written as t raised to half, and taking its inverse t raised to minus half. After integration, after integration, this can be written as, so integration of t raised to minus half, power get increased by 1, t raised to minus half plus 1 by minus half plus 1. Therefore, minus half plus 1 becomes plus half. Okay. Therefore, we get the answer as I is equal to 2 into root t plus c. Now again by back substitution t is replaced by tan x. Therefore, I is equal to, we have 2 root tan x plus c. Now let's see the next example. Integration of 3x plus 2 into root x minus 4 dx. Now you can see there, you will think that now which function is derivative of which one. Okay, so how to solve it? So let us consider I is equal to 3x plus 2 into root x minus 4 dx. Now put x minus 4 is equal to t. Therefore we will have x is equal to, shift this 4 to the RHS 4 plus t. Now differentiate. So derivative of x dx is equal to, derivative of 4 is 0 and into dt. Therefore equation 1 becomes integration of 3, these 3, and this x is now get replaced by 4 plus t here, and plus this 2 as it is, and into x minus 4 is equal to what? T, but it is now root, so root t into dt, because dx is equal to dt. Therefore carry out this multiplication now, 3 into 4 12 plus 3 into t 3t plus 2 as it is into root t dt. Now 12 plus 2 14 plus 3t, and this t can be written as raised to half dt, because if we write is in rational form, then it will becomes too easy to take a multiplication. So 14 into t raised to half plus 3 into t raised to half into dt. Now 14 t raised to half plus this t has power 1. Now base is same, therefore taking addition of the indices, 1 plus half becomes 3 by 2 dt. Now after integration, power get increased by 1. So 14 t raised to half plus 1, 14 t raised to half plus 1 plus 3 t raised to 3 by 2, this 3 by 2 plus 1, and upon same power, that is half plus 1, 3 by 2 plus 1 dt. Now taking this addition, half plus 1 3 by 2 and 3 by 2 plus 1 5 by 2 plus c. Now by back substitution, I is equal to, now here carry out this multiplication also, 14 2 are 28 by 3, and what is this t? X minus 4 raised to 3 by 2 plus 6 by this 3 into 2 6 upon 5, and into this t, x minus 4 raised to 5 by 2 plus c. Now the next example, cos 3x minus cos 4x by sin 3x plus sin 4x. Now what about this example? Using the factorization formula here, cos a minus cos b is equal to this one, and sin a plus sin b is equal to 2 sin cos. So using these formulas, we will have these calculations here, that is minus 2 sin 3x plus 4x by 2 into sin 3x minus 4x by 2 upon 2 sin 3x plus 4x by 2 cos 3x minus 4x by 2. Simplifying this, we will have here minus, again sin 3x plus 4x by 2, these get cancelled, isn't it? And here theta is same and sin upon cos, but 3x minus 4x by 2 minus x by 2, and 3x minus 4x by 2, that is again minus x by 2, and this negative sign is already there. Okay, but sine minus theta is equal to minus sine theta, and cos minus theta is equal to cos theta. Using these results, we will have here sine, this minus, due to this minus sign get absorbed, that is it becomes plus sine x by 2 upon cos x by 2, that is tan x by 2 dx, and is equal to its integration of tan is what, log of sec x, but here is x by 2, therefore log of sec of x by 2. And I have already told you that if there is any multiple of this variable x, then we have to divide by that multiple to the function. So here half, so divide by half plus c, that is you can write 2 into log of mod of sec of x by 2 plus c. Now here there is one more result or some integrals of this type. What is that? Now there are some integrals of the form a cos x plus b sin x upon c cos x plus d sin x into dx, and such type of integrals can be evaluated first by reducing the numerator to this form. What is that form? Numerator is equal to lambda. In place of lambda and mu, you can use the symbols capital A and capital B as per your convenience. Okay? So, lambda into denominator, this denominator, okay, plus mu into derivative of denominator. You can simply write mu into d by dx of denominator also. Now what you have to do, you have to find out these constants lambda and mu, okay, by comparing the coefficients of like terms. And when you will have lambda and mu, then substituting their values, you will have the given integral to the integrable form. Okay, so remember these one, these are some special type of integrals: a cos x plus b sin x upon c cos x plus d sin x. Okay, so remember these one, and how to integrate them. Numerator is equal to lambda into denominator plus mu into derivative of denominator. Find lambda and mu by comparing the terms, and by again back substitution you will have the required integral. Students, see, let us see one example. Sine 6x by sine tan x into sine 4x. Okay, now here this 6x can be reduced to the form 10x 4x. Now how we can reduce it? We can write 6x 10x minus 4x. So it is of the form sine a minus b, and this can be expanded as sine a cos b minus cos a sine b, denominator as it is. Now separating the terms, here sine 10x get cancelled and here sine 4x get cancelled. So here we have cot 4x dx minus cot 10x dx, and we have seen that is integration of cot x is what? Log of sin x. So here integration of cot 4x is log sin 4x, and again this 4 becomes a multiple as 1 by 4, and minus this 10 as a multiple 1 by 10 into integration of cot is log of sin this 10x plus c. So students, there are some solved examples are also provided there. You surely you see all these examples carefully and consciously, and we will see the next article in the next lecture. So have a